because up there on Mount Wilson in Pasadena, there's these towers, and they're sending out radio waves, and those radio waves are coming down here to the valley, and then they're coming to the building, and they go right through the walls of the building. I mean, some of them are bouncing off, but enough of them are getting through so that, guess what? Hey, there must be gaps in what appears to be solid. Are you all with me on that? Now, here's another interesting thing. You go to get an X-ray. Okay, your body appears to be pretty solid, but they shoot these X-rays into you, and what happens? It goes right through your what? Skin, not through your bone, because when it hits the bone, what does it do? It bounces back, and so your bone shows up on the screen. Okay? So, again, what appears to be solid is not so solid if you can look at it closely enough. Okay?
So your bone is solid?
What?
So your bone is more solid?
Yeah, I mean, I don't know what percent of the X-rays go through the bone, but enough of them bounce off so that we get an image on the screen. So there's lots of these. There's what's known as the electromagnetic spectrum. Any of you guys heard that before?
Yeah.
Oh, okay, good, because you're filmmakers, you should know about light. Light is just one part of the electromagnetic spectrum. It's one band, and also included in that is X-rays, gamma rays, radio waves, television rays, infrared rays. All those are different forms of rays, different forms of electromagnetic energy. Light is just one example, and there's these other ones too that are moving around the universe. Okay, light happens to not go through this very well, which allows us to see it. If we saw only, we see only a portion of the electromagnetic spectrum. If we saw radio waves, we wouldn't see these walls. We'd go bounce, you know, we wouldn't see them because most of them are going right, most of the radio waves are going right through the walls. Okay, so these are new things that science has discovered. New ideas, the microscopic. Now, the second one I mentioned was distance. So you can see things that with a so we have a microscope, but then we have a telescope, and with a telescope we can do what? We can see far away, which is rather a strange thing. You know, the first guys, they used it to look at the enemy troops, you know, on the battlefield, and then later on Galileo took it and pointed it where?
The sky.
To the sky. And one of the first things he looked at was he saw a big, you know, bright thing up there. He knew it was Jupiter, so he pointed at Jupiter, and lo and behold, what did he see? He saw bodies that appeared to be orbiting around Jupiter. Nobody had ever seen anything like this before. And this was like a whole new thing. You mean there could be other little miniature solar systems out there that other, you know, things rotate or go around? This was a completely new idea. Okay, you have to realize at that time people thought the Earth was the center of what?
The universe.
The universe, the center of everything. That we were the center of everything. That God had placed Earth here, and this was the center, and the sun went around us, and we were the supreme, you know, mammal, the top of the heap, and you know, he'd given us some special mission or something. But here Galileo was opening up the idea that, wait a second, maybe there's somebody actually came up then with there may be other planets out there with beings living on them. You know, this was a whole new idea at that time. Okay, so the distance, the telescope allowed us to change our idea of ourselves scientifically, that we no longer were the center of the universe. We were just one planet going around the sun among other planets going around the sun. And guess what? Those other stars out there, they finally realized that those were suns also. So there could be planets going around those also. Do you guys get what I'm saying here?
You said the telescope allowed us to change the idea that the Earth was not the center of the universe and everything revolved around.
Well, it helped. It helped bring that about. And I'm gonna show you over here. Did we talk about sunsets in here? Did I draw this picture? I didn't, did I? Okay, let's take a look at this. All right, what do you see here? A sailboat and what?
Water.
And what else?
The sun.
That's supposed to be the sun. Don't make fun of my drawing, but that's supposed to be the sun. And what's happening here? If this is the west, what's going on?
Falling.
Okay, she says the sun is falling. Is that what we all see? No, you're looking west. So we all would see the sun going down, right? But about 400 years ago, we realized that the sun doesn't move.
Okay.
What do you think of that, Jared?
Makes sense.
It makes sense. The sun doesn't move, but wait, we just said it's going down.
In perspective to us.
It's what?
In perspective to us.
In perspective.
To us.
To us, it's going down.
Yeah.
But, okay, but what, I mean, but wait a second, we know it's not going down. So why are we seeing it going down?
Because the
Depends on
Earth
where
is
you're
tilting. The Earth is tilting the opposite way.
Charlene, the Earth is doing what?
Tilting east, maybe. I don't know. And so it looks like the sun is falling west.
Okay, you're on the right track. You're on the right track. What's happening here? Is this sun going down?
No.
Or what Charlene said is the Earth is what?
Moving.
Which way?
This way.
I'm going to make it simple for you guys. Either this is going down or this is doing what?
We're moving. Going up.
Either this is going down or this is going up.